Have you ever wondered which stack gives you better performance in embedded GUI projects? Is it Qt running on Linux, or maybe native Android app implemented in Java or Kotlin? We didn't want to rely on opinions, so we built the same demo twice. We measured everything and compared both environments in depth. We also deployed Qt to Android OS to have a look at how Qt performs there. In this video, I will show you what we tested, how we tested it, and what you can take away, whether we are building for automotive, medical, or IoT. And if you want to see the full set of charts, data, and conclusions, you can download the complete PDF report using the link below. I am Lukasz Kosiński, CEO of Somco Software, an embedded software house and official Qt service partner. I really hope that you will like what our team has built at least half as much as I do. Let's get started. So first, it has to be stated that both frameworks, both ecosystems represent very different philosophies. Surely a lot of you noticed that naming this video, this PDF, Qt versus Android, is a bit imprecise, because Qt is a software development framework, while Android is an operating system, right? Qt apps can easily be compiled for Android operating system. But we had a feeling that if we would just compare Java and Kotlin versus Qt, just from a programming point of view, it would be a bit like comparing apple to pears, as both technologies are often used in some specific environments and they would have totally different advantages. So we needed to put a frame and add a context to this comparison. And this context is embedded devices development. I'm not making this easier here, as embedded development is also a really wide term. To my mind, the best explanation of embedded device is a closed system. It can be either a smart home system, medical device, or a new cockpit in your car. All of that fits in this definition. So, what would work better to develop an embedded device? Possibly the one with constrained resources. This is the question that we have been asking ourselves. Therefore, this is not only a comparison of operating systems or software frameworks, but rather entire stacks. Qt and Kotlin are two of the strongest options in embedded development space, especially in automotive, but not only. Let's now try to figure out which one makes more sense to you. To make it fair, we implemented the same GUI demo twice. One version was built with Qt on a Yocto-based Linux system, and the other one with Kotlin and Jetpack Compose on Android. Qt version was also released on Android. We will see results later on. It's a digital dashboard for an electric vehicle full of gorgeous animations and graphical effects. Of course, this comparison isn't tied to any specific industry, but we had to decide what kind of demo we wanted to build, and we went with this dashboard. Even if you work in a completely different field, the insights from this comparison will still make sense to you. Since it's a display for an electric vehicle, we thought it deserved a name, so we called it Perun, after the mythological Slavic god of lightning. All versions of the app run on the same hardware. Our partner Toradex developed system-on-module components, and we use their Verding SOM with NXP IMX8M Plus with 4 GB of RAM and 4 cores. So it's not the most constrained low-level device on the market, but it's also not the most powerful one. We decided it's ideal for such a test. And saying about implementation, we didn't simplify anything. Both apps were designed the same way, tested under identical conditions and benchmarked directly on the target device. This way, we could measure real-world differences, not just theoretical claims. Soon we will do the same for Qt, Flutter, Sklint, LVGL, so make sure to hit the like button and subscribe to our channel to not miss it out. This will also be phenomenal content, can't wait for the results. So, what was exactly measured? We looked at boot time, rendering performance, GPU and CPU utilization, memory consumption, and thermal behavior. Most of the people will now tell you that you have to download our white paper to get a single piece of information about the benchmarks, but I will not be so cruel. I will already tell you the most prominent discovery, the one about rendering performance. So, first, why does this metric actually matter? Nowadays, users expect smooth, fluid, and modern interfaces. It becomes especially important in graphically rich HMIs with animations, transitions, or real-time data. As you could see, this application has pretty advanced animations, including custom drawing, and here are the results. The Qt Yocto cluster consistently delivered around 59 frames per second. This performance was steady and predictable, which is often more valuable than raw frame rates. Kotlin, implemented through a Jetpack Compose, reached a lower level of responsiveness on the same hardware. In this test, it averaged closer to 32 frames per second. The animations appeared visibly less fluid, and the cluster's visual experience felt less immediate too. For the record, as Qt framework is cross-platform, we installed it also on the target with Android, which resulted in average 47 frames per second. Which makes sense, assuming that Android is adding its own overhead compared to minimalistic Linux. So actually that's a big difference. There is a lot of other interesting charts and data in the white paper, so find the link in the description and have a look. You'll find there a lot of surprising results, including GPU usage. So find out which framework offers better resources utilization. If you are enjoying this comparison of Qt and Kotlin so far, help us spread our message. A quick like really makes a difference. We would love to hear your thoughts in the comments. We regularly create this kind of deep dive content, so if you want to stay up to date, make sure to subscribe to the channel. And if you are interested in more in-depth articles and insights, we don't always make a video out of it, so you can also subscribe to our LinkedIn newsletter to stay in the loop. Okay, but you can always use more powerful hardware, so does this single benchmark tell you that Qt is a remedy in every case? No. So let's talk about that now. One of the aspects that should influence your choice is the specific environment of your industry. This comparison isn't just for one use case, it has strong implications across several industries. If you are in automotive sector, there Android Automotive is growing fast. It is a special variant of Android operating system with built-in Google services and plenty of useful features like a special hardware abstraction layer to communicate with various car components. Qt runs on top of Android Automotive as well, and you can talk to OS layer easily, but for many, Java and Kotlin seem more native for this platform. Saying about medical, I have a feeling that their Android adds too much complexity. So let me tell you a story. Once upon a time, we had a customer that had a Qt application running on top of Android tablet, and over time, Android got an update and it was no longer possible to control network Wi-Fi settings from the app. So the system API to do that was moved to private. But the majority of medical apps run in kiosk mode, and accessing system features would mean uncontrolled cybersecurity risk. So we had to migrate this application to a Linux system, and thankfully that was easy as it was Qt application, and with other frameworks it wouldn't be so easy. Also, not only in medical sector, but generally in other embedded devices, now there is a hot topic of cybersecurity and SBOMs. Qt has a lot of modules to implement GUIs, various connectivity protocols, databases, and so on. So that means that you can do already a lot using this single dependency. And on the other hand, if you go with Java or Kotlin, you would have to look for some extra dependency for many single features. Also, Linux and Yocto allow you to minimize your dependency list to only these packages that you really need. And the rule of thumb is that less dependency is better, so Qt and Linux would help you with that. And in IoT, where you might deal with even more limited resources, less memory and slower CPUs, Android stack is not really adjusted to such environment, while Qt has a special commercial option for MCUs. On the other hand, there are plenty of out-of-the-shelf HMI tablets with Android that you can use in industrial environment. So if your project doesn't really need any MCU mumbo jumbo, you don't really need Qt for MCU. And this way, you will probably get development in faster. So whichever sector you are in, understanding these trade-offs is a key. Now again, I won't go into every benchmark, that's all in the PDF, but let's just say that these two stacks show the very different characteristics, and rather most of them clearly show that Qt is able to deliver better performance in various aspects. Qt with Linux represents a lean, deterministic approach where you control every layer and minimize footprint, and Android, on the other hand, focuses on ecosystem leverage, development speed maybe, and integration with services. There is universally better. It really depends on different strategies. So what really matters? If efficiency, fast boot, excellent graphical effects, are your top priorities, Qt is likely your best match. If your focus is rapid development, Android ecosystem, and developers availability, there are probably more of them on the market, Java Kotlin might make more sense. It's all about aligning your business goals with technologies. This is not always true, but I often say that the best technology is the one you are familiar with. If you found this useful, please like this video, subscribe, and tell us in the comments which stack you are using, Qt or Android, and what was your experience so far. And don't forget to download the full comparison PDF. You will find detailed charts, implementation notes, and our decision framework there. The link is again in the description. So if your company is exploring embedded GUI development, or you would like our help with Qt, Android, or custom Linux projects, feel free to reach out through our website. Most of our requests are handled personally by me, so I would be happy to talk with you. Thanks for watching and see you in the next one.